All right, welcome back. And then here we are dealing with Euclidean Geometry of the Gauteng paper that was written in 2024 June. And then it says, complete the theorem. The line segment joining midpoints of two sides of a triangle is dash and dash. So what do we know? What we know is that if we're provided with a triangle here and we label this triangle ABC, if we come to line AB and we're told that here, this point here is the midpoint of line AB, and we shall call this point D the midpoint of line AB, and we come to line AC and we get the midpoint of line AC, and we join these two midpoints, right? What happens? We now call this midpoint of line AC E. Now what happens is this new line which we have formed, which is DE, it is made up of what? Two different midpoints. So the first thing that we know is that this line DE, it is parallel to line BC. That is the first thing. So here when they say the line segment joining the midpoints of two sides of a triangle is, the answer is parallel to the third side of a triangle, to the third side of a triangle, to the third side of a triangle. That is the first mark, and which means now we must give the second reason, right, with regards to this midpoint. So the first thing that we know is that these two, meaning to say that line DE is parallel to line BC. That's what we've written. The second thing, we know that line DE, it is half. So DE, if this is 10 centimeters, we will know that DE will be half of line BC. It will be half, right? So, and line DE is half the size of the third side of the third side. Remember, line BC is what we're calling the third side. We're saying this is side number 1, side number 2, and this is side number 3, the third side. So we're saying that line DE, it is half the size of this third side, and you would get your 2 marks. That's what they wanted. All right. We go to 5.2, whereby they say ABCD is a rhombus. ABCD is a rhombus with the diagonals AC equals to 16. So diagonals of line AC is equals to 16, and diagonal of line DB is equals to 30 centimeters. And what do we know from our rhombus? We know that our rhombus, when it has got diagonal lines, this point O here, it means that this side is equal to that side, and line BD, this side, is equal to that side. So when we are told that AC is equals to 16 centimeters, in other words, what they've told us is that from point A to point O, here we've got 8 centimeters, and then there is 8 centimeters. And when they say DB is equals to 30, it means that here we have got 15 centimeters, and then there is 15 centimeters. That's what we've been told. Now on 5.2.1, they say calculate the length of BC. We must know the length of BC. Now, what should we know? What we should know by now is the fact that if we're having a rhombus here, and then at the midpoint here we've got 90 degrees. So when they say that calculate the length of BC, what do we have? We've got the length of line BO, and we've got the length of line CO. And since here we're saying that there is 90 degrees, it means that line BC is the hypotenuse because it is opposite the 90-degree angle. So now we are going to say that BC squared is equal to BO squared plus OC squared. That is our Pythagoras theorem. So we continue by saying BC squared is equal to BO is equals to 15 squared plus OC, which is 8 squared. BC squared is equal to Now we go to the calculator and we find the value of 15 squared. 15 squared is equal to 225. So we write 225 here, plus 8 squared is equals to 64. BC squared is equal to, now we say 225 plus 64. And when we do that, it gives us what? It gives us the value of 289. So we've got 289. Now we say square root of 289, square root of 289. Therefore, our BC is equals to, then we simply say that the square root of the answer that we had is what? 17. So BC is equals to 17 centimeters, right? Why are we saying centimeters? Because here in the description we've been given the unit of measurement as centimeters, hence 17 centimeters is our answer. Now that we found that, we go to the next question. The next question now says that calculate line OF if OF is parallel to DC with F on BC. Now, where is line OF? We must calculate the length of line OF, and we have been told that OF is parallel to line what? DC. You can see there is a marking here that this line is parallel to that line. And line F is found on BC, right? So in order for us to find, to calculate OF, in order for us to calculate the length of line OF, we are going to utilize the information that we had here. But before we use this information, let's remember, we just found that line BC is equals to 17 centimeters, right? So here we say that there is 17 centimeters. But we were told earlier on that this quadrilateral is called a rhombus. And what do we know about a rhombus? We know that all four sides of a rhombus are equal. Meaning to say that BC 17, CD 17, AD 17, and BA is also 17. And now which part do we want? I'm just going to take a part that I want. So here I've got BC, and then from there, from this part of BC, now this is what I'm doing. I'm extracting a part that I want. This is point C, point D, and point B. And here we've got what? F. Here. So CD is 17, BC is 17, and remember what I said earlier on. Here and there, these two lines, it was indicated that they are parallel to each other, meaning to say that line FO is a midpoint, F is a midpoint to line BC, and O is a midpoint to line BD. Now, in other words, if this is 17, it means line FO is half what we were saying here, that if this is 5 centimeters and this is 10 centimeters, which means that line FO is half of 17. So in order for me to find line OF, I'm now going to say that BC is equal to CD, which is equal to 17 centimeters. And OF is equals to what? Half of line CD. So in other words, I'm now going to say OF is equals to, my line CD is equals to 17. So I say 17 divided by 2. Then what I get is 8.5 centimeters. That is the length of line OF. So here the trickiness was just in knowing the properties of a rhombus, right? Then we go to the next question. Next question, it's also tricky. Now, they say determine the size of O angle BF if O angle FC is equals to 64 degrees. What am I going to do here? I'm just going to erase here so that I can just extract from this diagram. And then it will make sense and you'll see that how easy is this. So they say that I must determine O angle BF. O angle BF here, this is the angle that they want, and I'm told that O angle FC is equals to 64. O angle FC, so this part is equals to 64 degrees. But now, if I'm to draw BCD again, I will say that I've got B, I've got C and D, right? And here I've got point F there. And then from there I join this. So this is point C, this is point D, that is point B. And here it's F, and then there I've got O. Now, it was marked for me on the question paper that line CD is parallel to line OF, right? And what have I been just told? I've been told that O angle FC is equals to 64 degrees. And they are asking me to find angle B1 here when they said O angle BF. Now, since I'm having these parallel lines, it means that my fan angles, they are activated, right? And remember what happens if I'm to extend this so that it can go back to being a rhombus. If line CD is parallel to line FO, it also means that this line FO is parallel to line BA. So BA is parallel to FO and FO is parallel to, all these three lines are parallel to each other. So here observe that I've got what? My F here, which is corresponding angles, meaning to say that B1 and angle B2, this angle B1 and angle B2, it is equal to this what? Angle F here, meaning to say that angle F or angle FC or angle FC here is equal to angle B1 plus angle B2, which is equals to 64 degrees. But now, if we come back, what do we know about these diagonal lines? We know that these diagonal lines, they bisect, meaning to say that angle B1 is equals to angle B2. That's when we used to say that this angle B1 would be equal to angle D something here, and this angle D, it will be equal to that one. So now, since I got this one, I now say that angle B1 is equal to angle B2, which is equals to what? Now, if these two angles are equal, I must now say 64 degrees divided by 2, which will give me 32 degrees. And since angle B1 is what was being looked for, I now say therefore O angle BF is equal to 32 degrees, because angle B1 and B2, they were bisected. So this is 32, that is 32. And when you combine it, it will be equal to this 64 degrees. That's all they needed. All right. Then the last question, it's a little bit difficult for most of the students. And I'll tell you why is the last question difficult for most students. You are taught about the area of a triangle, you're taught about the area of a rectangle, square, and all these other shapes. But in most cases, teachers, they don't teach about what the formula to find the area of a rhombus. So the question is saying determine the area of the rhombus ABCD. So what do we do? Now first we have to talk about the formula. Area of a rhombus is equal to half open bracket D1 multiplied by D2. And now this D1, what does it represent? The D1 represents the diagonal line, and the D2, it represents the other diagonal line. What do I mean? If you remember very well, we were told that the diagonal lines AC is equals to 16, and I said that from CO, it means here it's 8 and there is 8, and as an entire line, 8 plus 8 is 16. And we're told that DB is equals to 30. So from here to there, it's 15. From there to there, it's 15. So here what we are coming to do is now we are saying that area of a rhombus or area of rhombus is equal to half open bracket diagonal 1, I'm going to call it 8, multiplied by diagonal number 2, which is 15. And then I go to my calculator and say 15 multiplied by 8, 8 by 4, it's 8 by 5, it's 40, 0 carry 4, so I've got 120. 120 divided by 2 basically is equals to 60. but it's not 60 square units, it's 60 square centimeters, because the unit of measurement that I was given is centimeters. So I say 60 square centimeters since I'm calculating for area. Since I'm calculating for area, it's 60 square centimeters. What did I say? I said diagonal 1 multiplied by diagonal 2. What is the diagonal? This is diagonal 1, which is 8 centimeters. Diagonal 2 is this 15 centimeters. I multiplied those two, then they gave me 120, and then I said half, which is half of 120 is equals to 60 square centimeters. And just like that, we are done. You would have gotten all your marks. How many marks? 4, 7, 10, 12. So this question contained 12 marks. All right. On the next video, I'm going to be continuing with Euclidean geometry. So if you found this video to be helpful, please do consider subscribing, liking, and sharing the video. Till we meet next time, cheers.